Alright, welcome to Chapter 4. We are in the metric system. First off, we're going to go ahead and get rid of a small error in this. Right here, please take out is most commonly used. That's, I accidentally doubled that. Alright. Now let's get into it. So, the metric system is the most commonly used system of measurement in the healthcare system. And there's supposed to be a period, uppercase. Oops, another error. Okay, so drugs are most often labeled and ordered in milligrams. Okay, so that's the most often form that they appear in, although some are measured in micrograms or grams. So injections are normally measured in milliliters, although intravenous solutions may be measured in liters. Alright, so knowing how to convert units within the metric system it's an essential skill, okay? Essential skill for anyone performing dosage calculations, right? You want to make sure you're giving the right dose. So, looking at basic units of measurement, there are three basic ones. We're talking about the length of an object, or we could talk about the weight of an object. For example, if a dog weighed 3 pounds, or you can talk about the volume of something. Alright, so three basic units. Or types of measurement, excuse me, three basic types of measurements. So what are the units? Well, for length, most of the time, we look at meters. And the abbreviation that would be a lowercase m. Please do not use a capital M. Use a lowercase m. Alright, for weight, we use grams. That's the most common unit. Abbreviation for that would be a lowercase g. Or sometimes people use GM. Okay? Do not use a capital G. And volume. Most common unit we use would be a liter. And the abbreviation for liter is, this is the weird one, it's the only one who's a capital letter. That would be the capital L. Alright, so looking at the rules for a metric system. Alright, why do we have rules? Well, we have rules so everyone knows what's happening. There's order to what is being written. Because if you pick up a chart that another vet wrote on, you want to know what they wrote and be able to understand the notation that they were using. Alright, so here's 4 main rules. Okay, the first rule, you're going to use decimals instead of fractions. Okay, so stick with the decimals. Second rule, if the quantity is less than 1, you're going to use a 0 for the decimal point. So I've talked about this before, but you should be writing 0.25, not 0.25. And why is that? Well, sometimes when you're writing, the decimal point can end up looking just so small that sometimes you can't see it. So the danger here is if you meant to write 0.25 milliliters, but the person who picked up your chart saw 25 milliliters, that is a very different size dosage to give an animal, okay? That could actually be dangerous. So, to get rid of any confusion, you write that 0, and if the person can't tell where the decimal point is supposed to be, they can go and find someone and ask them maybe what the right calculation is supposed to be. Alright, so the third rule. You're going to write the unit after the number, okay, with a space between them. So here's an example, 3 milliliters. There's a small space between the ml and the 3. Next, you're going to use lowercase letters for the metric system abbreviations. Always lowercase letters. However, there's always got to be an exception. However, you're going to use a capital L to represent liters. Liters is a special one. So for example 1. Let's go ahead and correct the following for metric quantity and abbreviations. So take a moment and look at these and try to figure out how to write this correctly. Alright, for A, what is wrong with A? Well, notice the unit is in front of the number. That is not correct. We're going to swap that around. That should be 30 space mg, milligrams, 30 milligrams. So for B, what is wrong with B? Well, notice it's a decimal. So there should be that 0 in front of it. Let's go ahead and rewrite it with the 0. 0.760 grams. If I wanted to be really picky, there probably should be a bit more of a space between the G. All right, the next one. 1 1/4 ml. Well, if we take a look at the first rule right here, we should be using a decimal instead of a fraction. Okay, so we're going to go ahead and change that to a decimal. And the decimal value for a fourth is going to be 1.25 ml. And lastly, what is wrong with D? Well, it's in a decimal form. Nothing wrong with that. There's a space between the ml and the 4.5. That L right there, that is not a capital letter L. That should be a capital L. So we're going to write 4.5 milliliters with a capital L. All right, so there we go. We have finished correcting those abbreviations. So let's take a look at the next page. So the most common metric prefixes. All right, so prefixes on words, beautiful things. So we have kilos, a base unit, and then centi, milli, and micro. Okay, those are all the prefixes. So let's take a look at the value. So if we have a base unit, for example, 1, kilo would be times 1,000, okay, of our base unit. Centi would be dividing it by 100. Milli would be dividing that base unit by 1,000. And micro would be dividing it by 1,000,000. So what would that be for length if we're looking at the measurement of length? Well, from the measurement of length, we often look at a kilometer. Okay, a kilometer is going to be, if I look at my base unit first, for meters, remember we were talking about the base unit. Actually, you know what? Now let me go ahead and highlight our base unit because we talked about that previously. These are the base units we went over just previously. All right, so the base unit would be a meter. We'd abbreviate with that with an M, and a meter would be 1 meter. So the kilometer is going to be our base unit times 1,000. So that would be 1,000 meters. And the abbreviation for kilometer is going to be km. Oops, I gotta fit this in here, km. All right, so let's keep looking at length. For centimeter, that is going to be taking our base unit of 1m and dividing it by 100. So centimeter, commonly abbreviated as cm, and we take our base unit of 0.1 and divide it by 100, so we get 1.01 meters. Next, we're looking at millimeters. Okay, so we're just taking that meter value and tacking on milli in front of it. Millimeter. Well, what is the abbreviation for that? It's going to be mm. In a millimeter, we take our base unit of 1 and divide it by 1,000. So it's going to be 0.001 millimeters. Sorry, meters. 0.001 meters. Micrometers. Micrometer. Abbreviation for this one is MCM. And that, remember, we take our base unit and we're going to, let's get rid of that. Take our base unit and divide it by 1,000. And what do we get when we take our base unit and divide it by 1,000? We get a very small number, 0.12345 meters. Whew. All right. changing my screen a little bit here so I can fit more room in. So if we're looking at the weight now, the weight of an item. Oops, I wanted to use my pen, not my highlighter. The weight of an item. All right, so this time, our base unit for the weight, remember if you go back and check in the previous page, it was a gram. Which we said the abbreviation for gram was G, and that would be written as 1 gram. All right, so now we're going to tack on and fill in all of this, tacking each of the prefixes on to gram. So, tacking them on, let's go ahead and write it down. This would be kilogram, centigram, milligram, and microgram. Okay, the abbreviations for all of these. Abbreviation for kilogram is going to be kg. Abbreviation for centigram is going to be cg. Abbreviation for milligram is going to be mg. And the abbreviation for microgram is mcg. Okay, let's sort of follow a common pattern here. All right, so go ahead and see if you can write down what each of these would be in terms of grams. All right, so for a kilogram, we're going to take our base gram and divide it by, multiply it by 1,000. So what is 1 times 1,000? Well, that is going to be 1,000 grams. Okay, so for centigram, what you're going to do is you take your base value, remember, and you divide it by 100. So dividing it by 100, what do we get? Well, 0.01 centigrams. Now, doing milligrams, same thing's going to happen. We'll take our base unit and divide it, this time, by 1,000. Oops, I went red. That's going to be 0.001 milligrams, sorry. And lastly, for micrograms, we take our base unit and divide it by 1,000,000. So it's going to be 0.1234551. Ooh, gosh. M. Oop, there we go. Whew, a lot of stuff goes into this chart. All right, lastly, go ahead and see if you can write down, oh, actually, first let me give you the base unit for volume. Base unit for volume, remember, was liter. Abbreviation for that was capital L and 1 liter. Okay, go ahead and see if you can fill in each of the boxes with the prefix attached to liter. All right, so filling it in with the prefix attached, that's going to be a kiloliter, centiliter, milliliter, and microliter. All right, the abbreviations for these: kiloliter, centiliter, milliliter, and oops, gotta fit this in here, microliter. All right, so going ahead and filling in the same as previously. How many liters is a kiloliter? Well, that we just take, remember, our base unit. Remember, we're always going back to the base unit. Take our base unit and multiply it by 1,000. Well, 1 times 1,000 is still just going to be 1,000 kilometers. Sorry, kiloliters, kilometers, kiloliters. And then a centiliter is going to be 1 divided by 100, which will once again be 0.01, but CL. And filling in the rest of these following the same pattern we have been using. Just dividing our base unit by the different values. Oh, I just realized I was doing this one part wrong. That should be liters, because we're focusing off of our base unit of liters. Sorry for the confusion. All right. Ooh, that chart was a lot to fill in. So we're going to write the indicated amounts in the correct metric notation. Okay? Write the indicated amounts in the correct metric notation. 4 1/2 meters. 4 1/2. So remember, we need to use decimals. But first, I'll go ahead and write that. That's 4 1/2 meters. But we cannot have that fraction, so we're going to go ahead and do 4.5 meters. And there we are. We're done. For A, 7/10 of a kilogram. Well, let's see. I know 7/10 and a kilogram. What was the unit for kilogram? Take a look at this. Kilogram. Aha, right there is kilogram, which the abbreviation was kg. But remember, we cannot use a fraction, so we got to use a decimal, so that's going to be 0.7 kg. Remember that 0 in front of the 7, that is important. So 10 liters. Well, 10 is 10. And then liters, well, remember that one, that's just a capital L. So 10 liters. All right, 8/100ths of a milligram. Let's see, I know that is a fraction, that's 8/100ths. And then milligram. What was the units for milligrams? Where is milligram? Here's milligram. And the abbreviation for milligrams was mg. Okay. So going ahead with that, we get mg, all lowercase. But we cannot have that fraction, so going ahead and writing it as a decimal. There we go. Then 93 micrograms. Well, 93 is not bad. I can just write 93. But what is the abbreviation for micrograms? Let's try find micrograms. Here's micrograms. Oops, let me use my highlighter. Still figuring this one out. Micrograms. Right here. What is the abbreviation for micrograms? It's mcg. Okay. So 93 micrograms. mcg. And there we go, we are done. Last one, 62/100ths of a gram. Okay, so that's gonna be 62/100ths, and then a gram. The abbreviation for gram was just a lowercase g. We can't leave it like that because we can't have a fraction. So it's gonna be 0.62 g. Remember, we need that 0 in front. And there we go. All right, let's look at 4.2, converting within the metric system. So we're going to look at an analogy. First off, if we have $1, what would that look like? Well, you have a dollar bill, right? $1. There's 1 unit. And then that is the same thing as how many quarters? 1, 2, 3, 4 quarters. Now let's look at it in terms of dimes. How many dimes is that? Well, that is, I don't want to write all that out. How many dimes is that? That is 10 dimes, right? And then lastly, how many pennies is that? That's 100 pennies. Okay, so let me go ahead and really quick write this in. So that would be 4 quarters. Let's erase the quarters. Oh, that's a small little eraser. Slowly erasing. Okay. Okay. That was 4 quarters. And $1. Oh, that just looks hideous. Wait. Obviously, I'm still figuring this out. My sister is way better at these, but I'm learning. All right. $1. Okay, after much trial and error, we have figured this out. So $1 is equal to 4 quarters, which is equal to 10 dimes, which is equal to 100 pennies. So take a moment and first acknowledge these are all equal to each other, even though they are all different units, and they're also all different numbers. Okay? So here's my question to you. What can you notice about the numbers as they change from a larger unit to a smaller unit? Well, as I go from dollars to quarters, my number goes from 1 to 4. So it gets bigger, right? And then as I go from quarters to dimes, my number goes from 4 to 10. It gets bigger. And then I go from dimes to pennies, 10 goes to 100. So the weird thing is, as our units get smaller, our numbers get bigger. So as the units get smaller, the numbers get bigger. Okay? So that's going to be something you notice. If you're changing from a bigger unit to a smaller unit, for example, dollars to quarters, your number is going to end up getting bigger. But if you went the opposite direction, if you go from quarters, if we went from quarters to dollars, notice the number is going to get smaller. Okay. So if you're ever wondering which way it should go, just think of the quarter and dollar analogy. Let's go ahead and fill in the equivalent metric units. So 1 kilogram is going to be the same as 1,000 grams. Okay, and then 1 microgram is going to be the same as 1 milligram is going to be the same as 1 microgram. And then 1 gram is going to be the same as 1,000 milligrams. And then 1 liter is the same as 1,000 milliliters. Okay, so notice, these are good things to remember, have memorized. So when we're converting units, think about the analogy we had up here with the dollars. For converting units, you're going to move the decimal point to the right. If you convert from a larger to a smaller unit, okay? So the decimal should be moving to the right. For example, 0.01, you'd be moving your decimal over 1 more. For 2, move the decimal point to the left if you convert from a smaller unit to a larger unit. And we'll go ahead and see how this works in the following examples. Okay. Actually, sorry, take that back. That's just something to keep in mind. We're actually going to be using proportions to solve. So for example 1, we're going to convert the following units. And first thing I want us to notice is if we're moving from a larger unit to a smaller unit. So for part A, converting 9 liters to milliliters. Well, this, we're going to be converting from a larger unit to a smaller unit. So to do this, I'm going to go ahead and set up a proportion. First off, note, I want to know how many milliliters. So this is going to be my variable x, because I don't know how many milliliters I have. So my proportion is going to be, I want to figure out how I can relate liters to milliliters. Well, I know I have this relation right here, that 1 liter is equal to 1,000 milliliters. So I'm going to go ahead and use that for my proportion. And remember, a proportion is a fraction equal to a fraction. Okay, so my proportion. I know that 1 liter is the same as 1,000 milliliters. And I'm going to write that equal to 9 liters over, well gosh, I don't actually know how many milliliters there are in this proportion, but that's okay. It's x. X milliliters. So now, with this proportion, I'm going to go ahead and solve for x. So we're going to cross multiply. And what do I get when I cross multiply? Well, I get 9. We're just going to go ahead and drop the units for this calculation. 9 times 1,000 equals to 1 times x. Well, multiplying that out, what do I get? 9 times 1,000 is 9,000 equals x. So our answer is going to be 9,000. Well, what was x? X was our, oops, not that. X was our milliliters. And we know that that equals 9,000. So my answer is 9,000 milliliters. Okay, so we set up a proportion using an equation that we already know is true. Oops, that's the wrong one. We set up a proportion that we knew. We knew that 1 liter was the same as 1,000 milliliters. And then we equated that to what we were trying to find. All right. Let's look at B. How many meters are in 45 millimeters? Well, let's go ahead and we're going to start, remember, with a proportion. So I want to find an equation that equates meters to millimeters. Well, I know that 1 millimeter is equal to 0.001 meters. Okay, so you can go back and check your paper on that, but that is what we discussed in 4.1. So I'm going to use this equation for my proportion. So I'll do 1 millimeter. It doesn't matter which one you put on top or bottom. It may affect the way you work your problem out, but your end answer will be the same. It's okay. All right, so once I do that, now I'm going to fill in the other side of my proportion. And I need to line this up. So I have 45 millimeters. So a question you might ask yourself, am I supposed to do 45 millimeters on the bottom, or am I supposed to do it on the top? Where do I place it for my proportion? Well, what you're going to note is you want to have your millimeters on the top and then your meters on the bottom. So we do not want, so the proper place for the 45 is going to be on the top, matching up the millimeters together across the top. Which means, where did meters go? On the bottom. And we don't actually know how many meters we're using, so that is my variable x meters. All right, so now we've set up our proportion. We can go ahead and solve using cross multiplication. Once again, we'll just drop the units for the solving. So that's going to be 0.001 times 45 equals x, which is going to end up being 0.045 equals x when you plug that into your calculator. So the question is, what unit is this? Well, x was our meter value. So my answer is going to be 0.045 meters. All right, let's look at C. Convert micrograms to milligrams. Once again, we're going to look for an equation that ties micrograms to milligrams. Do we have an equation like that? Well, we do. We know that 1 milligram is the same as 1,000 micrograms. Okay? Once again, that's up in the charts that we went over earlier. So that's the equation we're going to use to create the first part of our proportion. So I'll just go ahead and use the micrograms on top. Once again, it doesn't actually matter which one's on top. It may change your solving a little bit, but not too much. All right, and then we got to figure out how to place what we know. So we know 3.4 micrograms, but we don't know how many milligrams. So that's going to be my variable, x. So plugging that in, well, I need to oops, I see a typo here. This is supposed to be micrograms. Micrograms. All right, so after my typo, let's see. We're gonna match up the micrograms to the micrograms, so the 3.4 should be on the bottom. So we have the 2 micrograms on the bottom. And then the milligram will be on the top, which we don't know, so that's my x value. And let's go ahead and solve using cross multiplication. And we'll drop the units for the solving for now. So that's going to be 1 times 3.4 equals x times 1,000. Oh darn, x is not by itself. That means we have to solve for x. Well, don't worry, we know how to do that. That's 1,000x, so to get rid of that 1,000, we're going to divide both sides by 1,000. And going ahead, moving that over there, we have 3.4 divided by 1,000. Calculating that out is going to be 0.0034 equals x. Oops, real quick. Don't want to box that. I need the units. What is the units for this? Well, the units for this, let's see, what is our variable? Aha, right here. Milligrams. So our unit is milligrams, so 0.0034 milligrams is our answer. And D, convert 75 kilograms to grams. Well, let's see. Do we have an equation that relates kilograms to grams? Well, yes, we do. You can go ahead and check your chart with this, but we have that 1 kilogram is the same as, or is equal to, excuse me, as 1,000 grams. So we're going to go ahead and use that for our proportion. So I'll just go ahead and plop 1 kilogram over 1,000 grams. And I want that equal to, well, what do we have? 75 kilograms to, well, we don't know how many grams. So that's going to be my variable x. And putting that in, let's see, remember matching them up. So the kilograms are going to be on the top. And the grams, which we don't know, are going to be on the bottom. So let's go ahead and solve this. Cross multiplying. I get, oh, and dropping the units, I get x equals 75 times 1,000. So x equals 75,000. What was the units I was solving for? The units, where's my variable? Aha, the units were grams. So my answer is going to be 75,000 grams. All right, last page. E, convert 200 milligrams to grams. Okay, go ahead, try pause the video and see if you can set up the proportion correctly, or set up a proportion and solve. All right, let's see. Can I find an equation that relates milligrams to grams? Well, yes, I have one. I know that 1 gram is the same as 1,000 milligrams. So I'll go ahead and use that in a proportion. All right, and then let's look at what we have. We have 200 milligrams equal to, well, we don't know how many grams. So once again, that will be my variable because we don't know how many there are. And we don't have a fear of the unknown here. It is algebra. So let's see, the grams is going to be on top. Okay, so we'll do x grams. And then the micrograms is going to be on the bottom. All right, let's go ahead and solve using cross multiplication. You can pause the video and try solve it by yourself first and check back with me. So let's see, that's going to be 200 equals 1,000 x. Ooh, x is not by itself yet, so I got to continue to solve. I'll divide by 1,000. Those zeros cancel, and I'm left with, let's see, 2 over 10 equals x, which is simplified to 0.2x. Well, my answer, I need my units. So what was my variable? My variable's unit was grams. So that's going to be 0.2 grams. Last but not least, F. How many milliliters are in 8.01 liters? All right, so what are we trying to equate here? We're trying to equate milliliters to liters. Do I have an equation that does that? I do. I know that 1 liter is the same or is equal to 1,000 milliliters. So we'll go ahead and use that to set up our proportion. 1 liter over 1,000 milliliters. And equate that to, well, what do we know? We know we have 8.01 liters. And we're trying to figure out how many milliliters that is. So since we don't know how many milliliters, it's a big word now, that's going to be X. I do not know, so it's my variable. Okay, so take a moment, pause, and try to fill in the proportion. So matching up the milliliters on the bottom and the liters on the top. There we go. Let's go ahead and solve this using cross multiplication. And we have X equals 8.01 times 1,000, which is going to be X equals 8010. Right, but we need our final answer in units. So let's see, our variable was milliliters, which means my final answer is going to be 8010 milliliters. And that is it. Yep, that is it. There we go. We are done. Please email me if you have any questions, and I'll be happy to give you any response.